Okay, let's talk about, first idea is this thing called the vertical line test. Or we'll call this the VLT. Some people call those as veggies, lettuce, and tomato, but we're going to note it as the vertical line test. Have you heard of this thing before? Okay, where have you heard it? In algebra? Algebra 2? Right, okay. So here's our formal definition for ourselves here, right? But I want you to take away today why the vertical line test actually works, okay? So for us, it's going to be this. If any vertical line intersects the graph in more than one point, so it's like an if-then statement, then we can say the graph does not represent y as a function of x. So I use a lot of shorthand there, so let me review it. So here's a formal definition that we've been introduced to. So if any vertical line intersects the graph in more than one point, then we say the graph does not represent y as a function of x. So here's some key terms here. In any more than one point, and it does not represent y. All right, so I have these four little sketches here. All right, one of them passes the vertical line test, and then three of them don't. So I'm pretty sure you can figure out which ones are which. But let's illustrate a little bit more. So as an example, right, let's take a look at this one here, this first oval. So for my x value, and let's say if I had a scale here at x value of -2, notice that I get out two different outputs for my y values. And we're not allowed to have that with functions, right? We have to have one-to-one. So for every input, there should be a unique output. So that's why the vertical line test is super important, because it tells us right away whether or not how many outputs we're going to have for one individual particular x. So in this case, our value x was equal to 2, and it diverged to two different directions, right? It could have been either this positive one, or it could be this negative one. So I had a positive answer and a negative answer. There were two different ones there, so it doesn't pass the vertical line test. Therefore, y is not a function of x. Is that pretty good? That makes sense, right? Whereas this one here, what do you think? Is this a function, yes or no? Yeah, this one does pass, so this one's all good to go, right? This one, absolutely not. Not a function. Doesn't pass the horizontal line test, or vertical line test, excuse me. And last one, nope, not a function either. Doesn't pass the vertical line test. Notice here I could have three different outputs for my one input, right? All right, cool. All right, first of all, does this picture represent a function, yes or no? Yes, how do you know? Pass the vertical line test, right? So number one, definitely passes a function. So yes, this is a function. Okay, now, so y is a function of x, right? What do I have labeled as my y-axis? Height. What do I have labeled as my x-axis? So we can say height is a function of time. Can you think of anything where height is a function of time? Growing, yeah, growing, right? Tides, growing, all those things, right? Very good. So if height is a function of time, which one is the independent variable and which one is the dependent variable? Does height depend on time, or does time depend on height? Yeah, height depends on time, right? So the height has to be your dependent variable. So height is our dependent variable, and time is our independent variable, right? So height depends on time. Height is a function of time. Very good so far. Okay, number two. For what values of x will f of x equal 2.5? What value of x will f of x equal 2.5? Well, first of all, you have to know what f of x is. Well, yeah, f of x is y, right? F of x is basically this graph right here. Okay? So I'm talking about this graph. So what value of x will produce an f of x equal to 2.5? Any thoughts? Any guesses? Yeah, 2.5. 7. How are you getting 7 out of that? Who sees it? How can you explain that? What do you think, Izzy? Yeah. Go up to 2.5, draw a horizontal line, see where it intersects your graph, and then look down on the x-axis. That's pretty straightforward. So what value of x would you say would produce a value of 2.5? 7.1? Yeah, so that would be approximately 7.1, right? What if I asked you what value of x produces an f of x equal to 1.5? What would you do? Yeah, go to 1.5. Notice I'd have this one here, and if I kept going, I'd have this one here, and if I kept going, I'd have that one there. So it is possible to have more than just one, depending on what your graph is doing, right? So for f of x equals 1.5, the values that give me that, I would say, would you guys agree with like 1.1, and maybe 3.9, and maybe 6? You guys agree with that? Yeah? You guys see how I'm getting those answers off information from the graph there? All right. Third thing I'd like to talk about is the domain and the range. All right, so I'm going to represent the domain and the range in two different ways. I'm going to represent it in set notation, and I'm going to represent it in interval notation. All right, and we're going to be responsible for both. All right, set notation and interval notation. First, let's talk about the domain. All right, what I like to do is I like to figure out, okay, where does the graph start? Okay, my graph starts here with information, right? And where does the graph end? Well, it ends over here, okay? Then what I do is I trace those points back down to the x-axis because after all, the domain is talking about the x-axis, and whatever part is highlighted, that's going to represent my domain. What do you think about that? Does that make sense? How I did that? So for us, we're going to say this. The domain, remember these are your x values, range, these are your y values. So for my domain for set notation, we're going to say parentheses, we're going to say x such that 0 is less than or equal to x, which is strictly less than 8. Now, why did I put a strictly less than 8 here? Can anyone tell me why that is the case? Yeah. Go ahead, Chance. Or who said that? Yeah. What'd you say? Yeah, there's an open circle there, right? So that point, even though it's on the graph, there's an open circle there, I don't include it in my domain, but I still say it because that's where the graph ends. Does that make sense? Okay, so if I was going to write this in interval notation, I would say bracket 0 because 0 is included, so we use brackets for the ones that are included, and then I go 8, and then I say parentheses for the ones that aren't included. So 0, 8 is my interval notation, and I have my set notation as well. Now we're going to do the exact same procedure. Yeah? Range? Okay, to find the range, I'll do this one in blue. So to find the range, okay, I say, where's the lowest point on my graph, and where's the highest point on my graph? They happen to be the same, but that's not always the case as the range. So I'm going to trace those points back to the y-axis, and everything that's highlighted between those 2 points counts as the range, because range deals with y values, right? So for the interval or set notation, we're going to have a set, all real numbers y, such that 0 is less than or equal to y less than or equal to 4. Or sorry, strictly less than 4, because that point is not included. So again, strictly less than 4 because at that point my y value is not included. So what would it be in interval notation then? Bracket, yeah. 0, comma, 4. All right, so for the last part here, so I've given you a graph. I've given you a function. F of x is that blue thing there. And what I'd like you to do is figure out the domain and the range and write it in both set and interval notation. And then we'll come right.
The brackets,
Mm-hmm.
-1, 5, and parentheses.
And then comma parentheses. Okay, who hands up if you agree with that? Yes, very, very good. So we can come up with the domain and the range. I would agree as well. And we have two different notations. We have set and we have interval. Depending on which one that we're asked to do, you're going to have to be able to do both.